Okay, so section 4.3 is a very short section, and all it has to do with is one example of completing the square to solve quadratic equations. Okay, because sometimes you're going to get into the situation where you won't be able to use guess and check, or you won't be able to factor it in your head, but it might be very much quicker to just complete the square as opposed to using the quadratic formula, which we'll do in the next section. This slide here just highlights how we're going to do that. Okay, suppose you're given an equation in this form. Okay, sorry, let's just backtrack for a second. Sometimes we given a quadratic equation in standard form. Okay, most often you will be. So you'll be something like this, where you can see that you won't be able to predict the factors by the nature of C, by the nature of B, by the nature of A. So you might be able to just complete the square, and then you'll see a very easy way of doing it. Or you actually might be given the quadratic equation in vertex form, in which case you might as well just solve it. Okay, very simply by moving this over, taking the square root of both sides, as you can see right here, and then you get both factors. So let's just do that. Okay, so you can see I go through the examples, okay, the possibilities. As you can see, it can get a bit convoluted here, but that's it. That's all there is to it. Okay, we're gonna do these two examples. So, example 1 is p squared minus 4p, and you know what? Yeah, p squared minus 4p equals 11. In this example, if say you're like, okay, well, let's just rearrange this like this, and let's try to solve this using guess and check, in which case I would say to you, good luck, because there are no factors of 11 that will very cleanly make 5. You're going to have to use some kind of fraction here. Make 4, sorry, which is not ideal to do in your head. So you can, instead of using the quadratic formula, you could actually just go ahead and complete the square here and then solve it that way. So for instance, let me just switch colors. Let's do this in green. So completing the square will look like this. We've done this many times. Half of 4 is 2, squared is 4, so you're going to plus 4. And instead of minusing 4, you might as well just put it to the other side right away. So you're actually going to get plus 4 on both sides. Notice how we didn't do anything, right? This is nothing. These 4's will cancel, and you're left with the original equation. Therefore, this is legal. So from here, you're simply going to, this is a perfect square trinomial. This is what it comes out to be. We're going to collect like terms over here. We have 15. Now we can just square root both sides to give us p minus 2 equals root 15. Okay, it's really plus or minus square root 15. Okay, and then we just solve for p, giving us 2 plus or minus square root 15, or 2 minus root 15. And this other guy here should be a plus. And that is it. So trust me on that, this is actually a very nice method when it can be used. Okay, it's very nice method when it can be used. This next one in blue. Hopefully we don't run out of room here. I'm just going to erase actually this whole little section. And yeah, this next one is the exact same type of question. Okay, no difference, except you're gonna be forced to use a fraction in this case. I'm gonna start up here. Okay, b squared, and we have negative 2x squared minus 5. I'm actually going to move the 2 over. This would be another example where you won't be able to guess this factor very easily. Okay, you perhaps could. You might be able to. Actually, I can see right now that it might be possible. But let's just, for the sake of this, see how this will look by completing the square. So I'm going to do the same thing as over here. However, this time I'm going to factor out 2. Okay, -2 from this first bit. So you can see how this might end at the end of the day. And you know what? I just had a very nice idea by looking behind at what I did before. Okay, before moving the 2 over, yes, this is much better. It's better just to factor out 2 at the start. Then you can divide -2 off of both sides, leaving you with the following. Now we can start from here. Yes, this is much better. So because now we can simply move that 1 over, the -1, over to the other side, and now we are in the exact situation as this one over here. They're both the same, okay, except we have a fraction. Okay, but no big deal from the fraction. When you take half of 5 over 2, you get 5 over 4. Squared is 25 over 16. Okay, let's make sure that I did that correctly. And I believe I did. 25 over 16. So what we have here is 5 over 2x plus 25 over 16 equals 1 plus 25 over 16. Now we can go right ahead, complete the square over here. We're going to get plus 5 over 4 squared. Now 1 plus 25 over 16 is 41 over 16. Take the square root of both sides. We're left with x plus 5 over 4 equals plus or minus 41, and the root of 16 is 4. Then we are finished. We just have to add the other one over. We get 2 solutions. Since the common denominator is 4, they have a common denominator, we can actually join this into one fraction. When we move to the other side, we're going to have minus 5 plus root 41 all over 4, or we're going to have x equals minus 5 minus 41 all over 4. Okay, that's one solution, and here is the second solution. And that's it. That's all I wanted to show you this one. Okay, that one technique, it can be very useful. It's actually particularly useful when you go into differential equations later on in your math career. Okay, always important to keep in mind completing the square. The next section is going to go to the big tool, the big hammer, you could say, of quadratic equations, which is the quadratic formula. So do the practice problems of completing the square, getting used to working with fractions, which you always should be familiar with from section 2.3, and then move on to the last section.